In this video, we show the trend line of the inverse hyperbolic sine, its logarithmic equivalent, and its Taylor-Maclaurin series sum. Begin with the function itself. So array formula: a sine h inverse hyperbolic sine of x values from negative 0.99 to positive 0.99. And we chart this. Insert chart. And we use scatter chart. Row 1 as header. And for the series, show the trend line. The type polynomial. The degree tenth. And the label, use the equation. For the legend, position at the right. So here's a trend line and polynomial of the inverse hyperbolic sine. Next, we continue with the logarithmic equivalent. So array formula: ln of the x values. Then we continue. We show the trend line, polynomial to the 10th degree. For the label, use the equation. And for the legend, position at the right. So, and we continue. This is, we add plus square root of x squared. That's x squared plus 1. So here's what their values are, exactly the same. And their polynomials are almost the same. And the Taylor-Maclaurin series sum expansion, which is a times x to the power 2n plus 1, where the value of n is from 0 to infinity. And the value of a equals array formula: minus 1 raised to the power n times factorial, that's times factorial of 2n. And enter. And we divide this, we completed the numerator. Now we continue with the denominator. So the denominator will have two parts. The first part of the denominator, 2n plus 1, so that's 2n plus 1. 2 times n plus 1. And the second part of the denominator is double factorial 2n squared. So times FACTDOUBLE 2 times n. And this is raised to the power of 2. Now we can complete the expansion. So array formula, series sum. That's array formula series sum of the x values raised to the power 2n plus 1, where 2n plus 1 starts from 1, incremented by 2, and the coefficient will be this range. And we'll show the trend line. Series trend line, the type polynomial, the degree tenth. For the label, use the equation. So here's the trend line and polynomial. Let's compare. Coefficient of x to the 0, 0. This is already 0. 1.62 times 10 to the minus 16. Coefficient of x, 1, 1, and 1. Coefficient of x squared is 0. This is 0. 1.38 times 10 to the minus 15, and this is also 0. Coefficient of x cubed, minus 0.167, minus 0.167, minus 0.166. Coefficient of x to the fourth, 0. This one is 4.36 times 10 to the minus 15, that's already 0. This is 0, x to the fourth. Coefficient of x to the fifth, 0.0729, 0.0729, and 0.0715. Coefficient of x to the sixth, 0. This is 0 because 6.4 times 10 to the minus 15, that's already 0. And 0 for x to the 6. X to the 7 minus 0.0345. Also minus 0.0345. And here is minus 0.0296. Coefficient of x to the 8, 0. And this is already 0, 4.45 times 10 to the minus 15. That's already 0. And also 0, x to the 8. Coefficient of x to the 9th, 9.58 times 10 to the minus 3. Also 9.58 times 10 to the minus 3. And here is 4.74 times 10 to the minus 3. Coefficient of x to the 10th, 0. This is also 0. That's negative 1.26 times 10 to the minus 15. That's 0. And 0 for x to the 10th. So this completes the use of the Taylor-Maclaurin series sum expansion to approximate the inverse hyperbolic sine and its logarithmic equivalent.